Hey everybody, how's it going? So, let's talk about divisibility. Oh my God. Let's not talk about how to spell it, but just what it is. So, I think we all know what divisibility means. It means like if you have a number 99 and you divide that by 3, are you going to get a remainder? That's what it means. Now, there is a trick for figuring out divisibility by 3 in which you add all of the digits together and then you see if that is divisible by 3. And you can repeatedly do that. 1 plus 8 equals 9. Okay. And I've made videos before trying to explain how this works, but I think that I can explain it without using modular arithmetic. And I think that that would probably be good for people who get confused by modular arithmetic. So, let me get a random number generator up here. Okay, so just any number here, 87. Okay. Now, first thing to realize with divisibility by 3 is that you can add or subtract 3, and the divisibility by 3 will not change. Now, if you add 1 or you add 2, then the divisibility will change, definitely. But 3, no. So, for example, if you added 3 to this, then you would get 90, and it's pretty easy to see that this is divisible by 3. But that's not the way that we're going to approach this here. We want to see this trick here. 8 plus 7 equals 15. 1 plus 5 equals 6, and it is divisible by 3. And clearly it's 1 less than 30, so it's 29 times 3. Now, adding or subtracting 3 one at a time works, but you can also add multiple at a time. So you could add 2 3s, or 10 3s, or 1,000 3s, and the divisibility by 3 is not going to change. So we can use this to our advantage to simplify this number right here. So we have 87, and I want to reduce each of these digits as much as possible. So how many 3s can I remove from here? Well, I can remove 2, obviously. So we're going to remove 2 3s, which is 6. I'll do it one thing at a time. So 81. Now this should have the same divisibility by 3 as this. It's just simplified. Now I want to look at this 8 here. Can I get rid of some 30s? That's 10 3s at a time. I could do it one at a time, or I could just see that I can do it twice and have 60. All right, so this would give us 21. All right, so you could do that with any digits that you have, and I don't really think that you need to understand any principle behind it, just knowing that you're subtracting multiples of 3, so that doesn't change the divisibility in any way. So we have 21 here, right? Now I want to show you something. I think that we can combine these digits. And I'm going to do that by adding 9. See, 9 is 3 1s. And we have established that adding or subtracting multiples of 3 does not change divisibility. So if we add these together, then we get 30. Now I think it's pretty obvious this is a multiple of 3 here. This is basically how the trick works, is you're adding 9s. So yeah. Yeah, let's try it again. let's say that it wasn't 21. Let's say that it was 22. Now, if you tried to add 9. If you tried to add 9, you would get 31. If you tried to add 9 again, then you would get 42. No, you would get 40. Wow. Don't learn math from me. Now, this is 4 times 10, so it cannot be divisible by 3. It's divisible by 2, and 2 again, and another 2, and a 5. Right? No 3s. So, yeah, you can combine digits in this fashion. So you could also go the other way too. I suppose if you wanted, maybe that's even simpler. So if you could subtract 9 from this twice, right? Minus 18, and that's going to give you 3. But if you look, 3 is equal to 2 plus 1. That's how the trick works, basically. It's just, this is a way of explaining it without using modular arithmetic. Now, you can do that for any number of digits. You can keep combining digits until there's only one digit left. And then, when you're done combining the digits, then it should be trivial to see if it's divisible by 3 or not. Let's try it without reducing the digits first with a 6-digit number. Here, let me put it in my random number generator here. I'm just using random.org, not sponsored. All right, so 5,012. All right. Now we want to combine this down to into a single digit by only adding or subtracting multiples of 3. Any multiples of 3 will do, but they have to be multiples of 3, and we have to be reducing the total number of digits every time. Now, honestly, if I were doing this, I would probably get rid of the 12 first, since that's a multiple of 3, be left with 5,000. I'd say, okay, clearly not divisible by 3. But let's try the technique we were talking about from before. So, how many 9s could we get here? 5 9s, 45. So that would be minus 45, right? And look at what it does. It just moves our 5 over. That's all that it does. So as long as you're working with 9s, that's what it should keep doing. And I think same thing here. Minus 45. And then that should give us 62. And then we should be able to subtract 60 here. Yeah, sorry, add my lines in. Yep, and then we are just left with 2, which is clearly not divisible by 3. And you can check it easily enough with the calculator if my mouse works, which apparently my mouse does not work. Okay, well, never mind. Okay, that's actually kind of bothering me. Why can't I use my mouse? Okay. Okay, when I'm recording a part of my screen, I cannot use my mouse. I really hate computers.